I'll be talking about it, and then Aji will be taking us on smart contract development. I guess testing, smart contract testing. So I will share my screen now and continue. Right, so I guess you can see my screen now. So like I said, we'll be discussing non-custodial BTC staking, which is one of our products here in Core. So okay, those of us that were present, and we know we've discussed this already, so I'll just say brief and then I'll go straight to practical. That is how to use this tool, right? This is an investment tool, I will say so. So the non-custodial staking, BTC staking, is a product or is an app or a system that allows you to stake your BTC, right? Your idle BTC, you can stake it and earn core. Okay, so you stake, but then when you stake, you're not giving it out to the person you're staking it to, which means if you're staking your BTC, you're not giving your BTC to core. No, it is non-custodial, which means it remains right in your wallet, just as we will see today in this class. So let's look at how non-custodial BTC staking works. You see, I'm just jumping because we've covered this in previous sessions. So, but I think this is important for us to look at today. Okay, so how non-custodial BTC staking works. With the non-custodial Bitcoin staking, Core Chain's protocol incorporate Bitcoin's holders as a third part of Satoshi Plus consensus. Yes. Core Chain's methodology for integrating Bitcoin staking centers on CLTV time lock. So what is this CLTV time lock? Okay. Aji, you said you can't see my screen.
The screen
Yeah.
is not visible.
Yeah, I can see your screen.
Okay, let me stop sharing and share again then. Can you see it now?
Yes, I can now. Yes, it's visible now.
All right. So now, the technology behind this non-custodial BTC staking is the CLTV time lock. Okay, CLTV time lock are Bitcoin native cryptographic feature that specify a condition under which the transaction output cannot be spent until a certain point in time has passed. This means that when you stake your Bitcoin, right, with this technology of ours, the CLTV time lock, this is a system that will lock your Bitcoin for a certain period of time, right? So even though your Bitcoin is in your wallet, it is not disposable to you. That means you can't spend it. Okay, it will be locked for a particular time period. The good thing is that you will decide how much time you want to lock your Bitcoin, right? All right, so now let's go to the guides. Okay, staking BTC on Core. Okay, so if you've been with us, we've explored this page already. So I'll simply go to our app. That is where we're going to stake our our Bitcoin. Okay, so this is it. Stake.CoreDAO.org. Okay, so this is the page. You can see stake.cordao.org. So my wallet is connected already. Okay, you can see if you're joining this session, I believe you should have your MetaMask wallet installed already. It shouldn't be a new thing, and how to connect it, because we've treated it in previous sessions. So my wallet is connected already. So now this is where you can stake your Bitcoin. Okay, you can see this is total core delegated. This is the total amount of core that has been delegated. Okay, this is the total amount of Bitcoin. Okay, 4,080 Bitcoin have been delegated here. Okay, so these are our validators, 23 over 30. I think this is the number of active validators right now. Total hash delegate, 83 Bitcoin blocks. Yes. So this is the page, right? Once you come to this page, you want to stake. Once you've connected, the next thing to do is to select whom you want to stake your Bitcoin to, or delegate rather. Let me see, delegate. Okay, so these are the validators here. Okay, you can see them. You can select from anyone of your choice. So for this session, let me use DAO mining pool 4. Okay, you can see it's active, right? So you simply click on it. You click on the name. Okay, so it opens like this. Okay, so this is this person's statistics. Dedicated coin, 2,271,000. So this is how much coins have been delegated to this person. Okay, this address, I think, has delegated this amount. Okay, this is okay, core holders. Let's see Bitcoin records. Okay, so you can see how much. No, this is okay. This is transaction records, right? Okay, well, to stake, if you want to delegate, you come here, okay, and then select BTC. Okay, you select BTC. Now it's going to ask you for your wallet. Remember, in our previous class, we spoke about a Bitcoin wallet that you need to be installed, which from our documentation, they prescribed either Unisat or XPass. So for me, I installed Unisat wallet. So I'll click it. So you can see, once I click it, this is the app where it returns for me to be able to stake. So you can see here, I can select the amount of Bitcoin I want to stake. This is the time period, right? When you click it, it brings out the calendar for you to select what time period you want to stake for. Okay, so you can see you are you're delegating to this person. Okay, and then this is your address, Bitcoin staking address. Yes. So unfortunately I don't have any Bitcoin to stake now, but if I do, I would have just confirmed delegation here. Okay, and then so I can proceed from here, but let me go back to our documentation and show how it works there. Okay, so you can see from here, you can see where we connected wallet, right? What's the next thing here? Wallet is selected. Okay, here they selected this validator to stake to. Okay, here you can see, so you can see we've been through this process, right? Delegate and then select BTC. So you connect your Bitcoin wallet here. This is what this image is talking about. Okay, yeah, connect. And then this is the last page we were, right? You delegate here. Select it, your time, and then okay, yeah, network priority. So this is slow, this is normal, this is fast. Okay, anyone you select, depending on the gas fee that you will be charged. Okay, so you confirm your delegation, and then very important, there's a script that will be returned to you when you delegate. Okay, this OP return script. So whenever you delegate, be sure that you receive this, okay, as a receipt, okay, before you sign. This is what you will use to claim your Bitcoin. This script here. So you have to copy it and keep it. So okay, verify transaction submitted. Yes, so by this time your transaction will have been submitted, and then where is this? Okay, so whenever you stake, make sure that your transaction shows pending here, and then finally rewarding. Okay, this is very, very important. When this is done, then you are done delegating your BTC. So I will stop here so that Aji will continue with smart contract development. Subsequently, perhaps next week Friday, I will show us how to redeem Bitcoin. Okay, the Bitcoin that you've claimed. That is very easy, and this is it here. You can also go through it. I have dropped the link to our documentation page on the group. If you still need it, you can request for it. If there's any question now, I'll take them before Aji continues. Thank you. Any questions? Aji. Aji, are you on the call? Hello, Aji. Wycliffe. Hello.
Hello, I can hear you.
Okay. I can't hear Ajidoku. Okay, so it looks like Aji is having some technical challenges. Let's wait for a while if he returns. Let me see if I can contact him on other phones.
My network. I think I was having network challenges. Hi, can you hear me?
Yeah, I can hear you. Welcome.
Okay, Wycliffe, you're with me, yeah?
Yes, yes.
So okay. So today I'm going to talking about is I'm going to be talking about unit testing. Wycliffe, you've done Web 2 now, so I believe you are familiar with testing. And let me just come here. And unit testing is the process where you test the smallest unit of code. It helps ensure code quality, and it's an integral part of software development. So, Daniel, I believe you helped, you spinned up Haddad contract last week, yes?
Oh,
Daniel?
yes.
Uh-huh. So, when you spin up a normal Haddad contract using the guideline from Haddad.org, it gives you something like this. Let me increase my screen. So it gives you have your contract, you have your ignition, you have your node modules, the test and type chains, the hardware config, and so on. So today we're doing testing, and before we test, I want us to go through the contract. So this is a simple lock contract. What it does is just like a simple version of the staking that Daniel spoke about. So this contract has two state variables. I believe we talked about state variables. We have the unlock time. It's a public integer. We have the address payable. So we'll make addresses payable so that they can be able to receive funds. And the name of this address is the owner. So we have it has one event, which is the withdrawal event. So it's used to emit the event with when it happened and the amount. So the constructor is a function that runs on deployment. So it takes in. So in essence, this contract, when you want to lock your funds, you specify when you want to unlock it. Then you call the function with a payable. It tells this is the owner and this is the unlock time. It sets it. So the function withdraw, it has only one function and it's withdraw. So what withdraw does, it just allows you to withdraw your funds. Are you with me? That's what the function does. So these two blocks are require blocks. They are checking. It requires that the block.timestamp is the current time. So it requires the time it's equal to or greater than the time you set to unlock your money. So you see, if it's not up to, it will tell you can't withdraw yet. And it still requires the message.sender is anybody that calls a function. So it requires that you are the owner of the contract. So if not, let another person not be able to come and call your fund to come and withdraw your funds. So if all conditions are met, it emits an event that says so and so address at this time withdraws this money. Then it transfers the money to the balance. But this is just the contract, and you can always go over it again. So what I want to concentrate on today is the test. So Hardhat gives us an environment where we can test, and you write your test using whatever language you use to spin up Hardhat, either JavaScript or TypeScript. So I used TypeScript, and you import some things. So the first import we do is from Nomic Foundation. So we import load fixture. So what load fixture do is it enables us to set up and get a snapshot of the state on deployment, and we are importing time. Time is just because we are working with time, so that we have access to time in the environment. So any value to help us to, in case a function requires more than one parameter and we really don't need the second parameter, we can just pass in any value. And we import expect from chai. Am I too fast? Are we getting me? Am I confusing anybody? Am I going well? Please let me get feedback from you guys. Daniel, Wycliffe.
Yeah, I'm good.
Okay. So we import expect from chai, so we can use it in our testing. And to test, we need one general box one general code block where we do all our testing, and it takes in two parameters. The first parameter is the name of the contract, in this case, which is lock as a string, just to be sure. You see, this is the contract name lock. So it takes in the name of the contract and it takes in a function. So now, function is where we'll be doing our testing inside the function in the describe. So in this function, the first line is an asynchronous function, and what we use this async function to do, we use this asynchronous function to set the states, the deployed state. So it's going to be a snapshot of our deployment. And if you remember in our contract, let me split my screen into two so that I can be working side by side. Good. So lock.so, let me have it here. So you see, constructor is the function that runs only on deployment, and we simulate that here. We set the variables that are supposed to be there. So we set a constant 1 year in seconds and 1 GUI. So what we want to use these two constants to do, we want to use 1 year in second as our unlock time, and we want to use 1 GUI as the value that we passed as payable. So okay, so you see locked amount is now 1 GUI and unlock time is the latest time plus 1 year. So you see how it's broken down. So this line 21, let me just make it big. I would like it to be big so that on line 21, this is an array of signers. Good. Contracts are deployed using the first signer, yes, by default. So always if you call on the deployment, it's the owner that will deploy it. But you can name this whatever you want to name them, and you can destructure it up to having 20 addresses in it. So we do await.ethers.get signers. This is assigning these signers. We're getting signers from ethers. So signers are like account, like contract, like EOAs, like externally owned addresses. So an ethers provide up to 20 of them. So now whereas this is the contract, while this is a contract instance we're creating in this line. This line, a contract instance is created. It gets the contract factory lock. If you remember, lock is the name of our contract here. Contract is lock. So we save a snapshot of the contract in lock and we deploy that contract. So on deployment, we return the deployed contract, the unlocked time, the locked amount, the owner, and another account so that we can use it for our test. So now that all these are inside an asynchronous function. Yes. So this asynchronous function is named deploy 1 year locked fixture. So this is our deployment fixture. So for the tests now, there are multiple cases that we can test, and you do each test case inside a describe, and a describe function takes in 2 arguments. It takes in the description and a function. So now the first block is deployment. We should test deployment. I like closing my codes like this. So in deployment, to test that the contract is deployed correctly, we have almost how many cases? Almost 4 cases were tested. The first case is it should set the right unlock time, and that's the first argument. Then the second one is an asynchronous function. So what it does now is we are now destructuring. You see what we returned on deployment. You remember on deployment we returned the lock, unlock time, locked amount, owner, and other amount from deploy 1 year lock fixture. So when we come here, we remove it from, we are loading the contracts from deploy 1 year load fixture, which is an instance of our deployment. Then we call out the lock and the unlock time. So we want to check if the right unlock time was set. So now we expect the unlock time to be equal to the unlock time we set. This unlock time is coming from the contract itself to equal to the unlock time that we passed in here. That's 1 year in seconds. So that's the first test to be sure. Then the second test case is it should set the right owner, and it's just simple. We always just call the instance owner of from the contract's owner, and expect it to equal the owner that was passed in here. Then it should receive and store the funds to lock. That means on deployment you pass in 1 GUI, and we expect the money to remain in the contract until we are ready to store it to withdraw. So as usual, we destructure the deployed contract. We take in what we want. We want the contract itself and the locked amount, and we just expect the balance of the locked contract to equal to the locked amount. So I don't know if I'm flying or I'm being too fast. Then the third instance is it should fail if the unlock time is not in the future. So if you want to deploy the contract and you are trying to choose an unlock time that have already passed, it should fail. So, and this is an instance, we get the latest time, and we redeploy the contract here with the latest time with 1 GUI, and we expect it to be reverted with unlock time should be in the future. So now if we test, you run npx harder test. Let me test just this one that I've explained, and you can test only an instance by using the dot only. So when we do npx hard test. You see, it sets the right unlock time, it sets the right unlock amount. So now let me just, to prove that this thing works, let me alter something. Should equal to unlock time. Where's unlock time? Let me unlock time. Good. Let me temper with it and do something. Let's paste it. Let's do this one. Should be unlock time 1, and it should be, let's save it like this. Let's return it here so that we can get access to it. And let's see. Okay, unlock time. Where are we checking it? Okay, yes, let me use unlock time 1 and equal to unlock time 1. So instead of this, let me make it like this so that okay. Sorry, I'm just trying to, so it should, so that we can see the difference. It should be -1 here in second. So if I try to run this test now that I've changed the parameters, 1 will fail, 1 should fail. Good. You see, the assertion failed because it's expecting, it's this one that I changed. So it's expecting it to be the unlock time, not the time that I altered. So it proves to you that your smart contract is working. Now if I run it again, it should, you see, it's passing. So now if I come here and I destructure here, I'm just altering it and I put unlock time 1. No, unlock time D, unlock time here. So this one is expecting, okay, no, this is not what I want to change. It should fail if the unlock time is not in the future. Okay, good. So latest time, let me do something plus 1 year in seconds plus, I'm just editing, sorry, I'm editing it. Unlock time plus Control V. So let's save it like this. So now I'm adding a year to it. That means I'm picking it to the future. It should fail. Good. You see, it was expected transaction to be reverted with the reason unlock time should be in the future, but it didn't revert because I added 1 year to it, and hence it's in the present. So you see, that's what testing does. It allows us to try our code and make sure that it's in working condition. So before I call it a wrap, Wycliffe, is there anything you will need me to buttress on or to explain further? Any confusion, any misunderstanding? Daniel, are you with me?
I think no. Everything is you've presented everything well. And for TypeScript, it's
Yes.
from what I can see, TypeScript is it basically contains most of it are English statements, and I think I should also check it out because previously I was working on Java and JavaScript, and they are a bit technical. But for TypeScript, I think all is well.
Okay, and TypeScript is usually, so to some people it can be crude, but it's easier to understand and it makes sense, and it makes Web3 easy, as you can write your contract in Solidity and you run your test in TypeScript. So if you go through it will be easy. It makes you, because the problem is deploying contracts cost money, and imagine you write a contract and you deploy it, then you discover there's an error. So basically, it's advisable you run your test, and when all your tests are passing of every scenario that you can check, then that way you are free to deploy your contract on the mainnet with your funds. Because, for instance, you go deploy and it you go and deploy and there's an error, it will still cost you more to redeploy. So that's why unit testing is a joy to use, and I'm glad it's straightforward to you. So if there's no any other question, Daniel, I think we can call it a wrap for today.
Yes, if there's no further questions, it's good. Excuse me.
So thank you very much, Wycliffe. It's painful that we have so much information to share.